How can schools develop the next generation of cryptographers when math skills are so bad? It's the same question for physicists, engineers, applied mathematicians, bioinformatics people. It's a difficult one, right? Mathematical competency is not where it needs to be. I think the big issue is that math is not taught correctly. And there's a big debate in the mathematical community about the proper pedagogy for mathematics and when and how to introduce things and how do you transition from arithmetic to algebra to calculus and so forth. And also, when do you do abstract problem solving? For example, most high school students who have never read a book called How to Solve It from George Poya. And ironically, that is the book that many Eastern Europeans, when they went to high school, read, because it was like the canonical book on problem solving for high school students. And it gives you a completely different view of mathematics than just solving a linear equation or zeroing out a matrix or something like that. So it's a difficult question in general, but I think the key is having a pedagogy that encourages people to look at mathematics as not just adding things and subtracting things or solving an algebraic equation, but in mathematics as a collection of mental tools, cognitive tools that allow you to think about how to solve problems. And I think the first part of surveying the damage that's done by modern pedagogy is just asking people how much do they like story problems, and pull them in 8th grade or 9th grade or something. And if they love them, you're doing something right. If they hate them, then you're doing something fundamentally wrong in the way that you're approaching teaching mathematics. Now, getting to the level of being a proper cryptographer, very few human beings do that. It's just a lot. You have to know a lot of applied computer science, theoretical computer science, and then you have to know a lot about certain topics of mathematics like number theory and combinatorics and probability theory and so forth, at least comfortable enough to actually manipulate these things and work with those abstractions. That takes a gargantuan amount of passion, and most people won't get there. Now, that said, most people don't need to be cryptographers. In fact, the vast majority of people who are interested in information security don't go and become proper academic cryptographers like our chief scientist. They go get a bachelor's or a master's degree in information security, and they become appliers, and they think about the whole space, and they think about how do I keep something secure, and physical security, theoretical security, software security, hardware security, these types of things. InfoSec is a completely different thing than cryptography. And it is a consumer of cryptography, no doubt, but that's mostly a black box to a lot of the InfoSec people. They just assume the algorithms are correctly implemented, and they assume the security proofs are right, and they think much more about the human elements and basically how do you deal with social engineering and how do you build systems that are secure despite the fact that they will fail, and they have redundancies built in and so forth.